So we're going to start with a little example, okay? And the example looks like this. We've got a robot, okay, in a very simple little toy environment, okay? And in this environment, there's a ton of stuff. There's maybe a sofa, a hat rack. There's maybe different types of surfaces. And what I want is, I want a little NLP program where I can type a command for the robot in text, and then I want that robot to execute that command, okay? So if I tell the robot, drive to the sofa and then turn left, then I want it to do that. If I tell it, drive forward until you get a hat rack, then I want it to do that. If I tell it, turn around until you find a brick road and then drive on the brick road, I want it to execute that. Okay, cool. Solve this problem for me. Like, what's the dumbest possible thing that you can do in order to solve this problem? Excellent. So I think that's a very good strategy. As I like, the dumbest grade 1 solution that you can do is to write a little program that looks for keywords, and maybe you've got a massive if-else statement program where it says like, oh, if I see forward, then move forward. If I see the keyword chair, then do something. And you've basically built what they would call a rule-based system, right, with a whole bunch of if-else statements. Okay, that's a very good first approach, right, that you can do. Okay, and you can maybe do something slightly more complicated. So look for patterns. So you maybe look for like if you see the keyword spaces, then maybe you try and look, is the keyword 2 maybe before it, or is it 1, or is it 3, something like that. So you can maybe, instead of just looking for keywords, you can do something slightly more intricate where you're like writing a little program that looks for explicitly for patterns. Okay, cool. It's a very solid first approach. What's the level just above that? Okay, so this is what you did in primary school. Now grade 2. You can make it completely random. Okay, so that's pre-primary school. Okay, that's pretty bad. Okay, but it's a solution, right? Okay, cool. Okay, let's think about what's the machine learning route. Get a bunch of people maybe playing this thing, and record what is typed, and then record what action happened when that thing was typed. And you build up a little training set of previous instructions and the corresponding action, what took place, okay? And then what we're going to do is we then have a bunch of input-output pairs where your input is a previous sequence of characters or sequence of words, and your output is what happened in that specific setting. So I actually have this data set, if I can find it. Okay, here it is, okay? So here is, this is actual data from that environment, okay? So someone typed the command, face the octagon carpet, okay? And then the output in that specific setting where that robot was that the robot had to turn and then verify that it was in front of a yellow hallway. Okay, so that would be the input and the label. So input would be your X and label would be your Y. The second from the bottom is a nice one, turn left, okay? That was the command that was typed, and the corresponding Y, the output to the model in that case is turn left, okay? So go forward about 2 segments to the intersection containing a chair, travel steps 2, verify at chair. Okay, so that would be your output. Okay, great stuff. So we've collected the data set of this, okay? Now we receive a new input to the model, okay? We receive a new command. It's not exactly in our data set, but we receive a new command, and now we want to execute the command. Okay, we're in machine learning land. Okay, cool. What is your model? What is the approach that we're going to take? Okay, the simplest approach, one of the simplest approaches that we can take. So if I write a new command, go 3 spaces forward and turn left, what is the simplest thing that we can do in this case? What's the simplest machine learning model that you've ever heard of? Nearest neighbors. Yes, that's what I was looking for. So you get a new input sentence. You write in a new input sentence, and then what you do is, let's do the dumbest thing, 1 nearest neighbors. I find the closest sentence to my input. I see, oh, it's that third one there, and I just execute whatever is the corresponding Y to that third sentence. Okay, That is the stupidest possible, not quite, I mean, you did rule-based stuff and random moving. Okay, so it's almost the stupidest thing you can do, but it's a very sensible first approach, I think. Okay, but there are some questions that we need to answer in order to do that. How do you actually, if I write a new sentence, and like here I have a little, like go forward or something like that, how do we actually match it to the stuff at the top? How would we do it? Bag of words, that's a nice one. So you just look at the number of words that overlap between them. I think that's a pretty good one. You've actually skipped a few steps already. Okay, so what you've done is you've decided already, I'm going to model words. Okay, before that, there's actually already a few things that you need to do. The very first step is you probably need to figure out that you might want to normalize your text in a way so that it's consistent, okay? And with that I mean like maybe the, let me just see. So here we've got position 7 and the character 7, right? Here right at the bottom, the last one, here we've got the word 2, okay? Maybe we first want to process everything and map all the TWOs to the character 2 so that everything is consistent, okay? So that's maybe one thing we would want to do. Okay, cool. Then the second question you need to answer is, okay, what units am I going to use? Is words the right unit? Should I maybe I should use characters, or maybe something in between? Okay, so there's a second decision that you need to make. And then the third thing that you need to figure out is how I'm going to match my input to the output, to the stuff that I've observed. If I give you two sentences and I ask you how similar are they, you need a way to quantify that, okay? Bag of words to basically count how many words does the two sentences have in common is one way, but we're going to look at another way as well, which is called the edit distance, which basically says how many edits should I make to my input. So I just want to formalize this very quickly. So we want to know how should we pre-process the data? Should we map 2 to 2, or maybe the other way around to make it consistent? And this is the task. This task is called text normalization. Then the question is, what is our basic modeling unit? Are we using words, characters, maybe something in between? So the question is, what units will we use? And the process of going from your normalized text into your units, that's called tokenization. And then this last question is, how do we measure the distance between two sequences? And here's a little stupid example, but is the input word forward more similar to this sequence or to this sequence? And how can I quantify that? Okay, and here we're specifically going to look at the edit distance as a way to compare two sequences. Okay, excellent. And that's just the like little story for this whole section.